this network, it is given that is potential difference across 8 ohm resistor is 48 volt. We have arrangement of resistors like this, and we are asked what is the potential difference across X and Y. So if you look over here, we see that this is a node. Let's give it a name A, and we can also call this as B, and let's call this as C. Now over here, we clearly see that these three resistors, they are in parallel, and 24 and 8 ohm, they are in parallel. When they are connected over here, these are wires, these are conducting wires. So even if we make a combination like this, whether we have arrangement like this, or these are wires, this one same thing, like this or like this is one same thing. Similarly over here, what we can do is, we can connect it like this and we can connect it like this. We can collapse it further, so it means even if we directly connect it over here, we directly connect it over here, and this one, we connect it over here and we connect it over here, that is one same thing. So we see this and this, they are in parallel, this and this is in parallel, and when we say 48 volt is the potential difference across 8 ohm resistor, certainly that is, it is a potential difference across B and C also, and that is going to be the same potential difference across 24 ohm resistor also. So if we redraw this network, so this is 3 ohm over here, this is X, this and this, that is parallel, so we can say 1 R equivalent if we talk about this, so it is 1 by 20 plus 1 by 30 plus 1 by 60, so 60 is going to be LCM, so this is going to be 3 plus 2 plus 1 upon 60, so R equivalent is going to be 60 divided by 6, that is equal to 10 ohm. So this is going to be a 10 ohm resistor. So what we can do is, between A and B, we can replace by a 10 ohm resistor. Between B and C, if we similarly we say between B and C, 1 by R equivalent between B and C, if we talk about, this is B and this is C, so between B and C, 1 by R equivalent is 1 by 8 plus 1 by 24, 24 comes out to the LCM, so it is going to be 3 plus 1 by 24, 1 by R equivalent. So R equivalent comes out 24 by 4, that is 6 ohm. So this is between B and C, it is 6 ohm. B and C, it is 6 ohm. And over here, this is 1 ohm resistor. This is X, this is Y. Across this B and C, if this is 48 volt, if across B and C it is 48 volt, we can use V is equal to YR. When we use V is equal to YR, potential difference across B and C, it is 48 volts. So 48 is equal to I, we don't know what is flowing in this, I into R, R is 6. So 48 by 6. So I comes out to be 8 ampere. Whatsoever current flows through this, the same current will flow in one single arm. And if we talk about this, whatsoever current comes over here, it will get divided into these 3 arms. Once again, it gets divided over here and combines to once again, it will make 8 ampere only. So V, potential difference across this, is equal to I into R plus I into R plus I into R plus I into R. So now these resistances, we see that is there in series only. 3 plus 10, 13, 13 plus 6, that is 19, 19 plus 1, 20, 20, V is equal to I into R, I is what, 8, R is what, 20 ohm. So this comes out to be 160 volt, that is VXY comes out to be 160 volt. It is a potential difference across X and Y.